Hello and welcome to a quick tutorial on how you can create a multi-view diffusion demo using HuggingFace transformers and Gradio on top of PyTorch, right? So firstly, what is multi-view diffusion? If you look at the screen in front of me, you can see a bunch of images and then different views next to it, right? So it's like a 3D render all around the image. And what you can do is you can create an interface where you can drop an image and it'll do this using a diffusion model. And I will show you exactly how to do this, right? First things first, I'll show you what it's capable of. So I can go to Google, I can search up a teddy bear, and I can go and put it into this demo. Right, it'll take a sec to load up, and then I can press submit. So what this does is it sends the image to the GPU. Now the GPU's doing whatever it's been told by the functions to generate 4 different views of it. So as you can see, that's the side view, that's the front view, that's the other side view, and that's the back view. Pretty damn cool, considering the fact that, hey, this was literally a 2D image and now it's given you 4 different views of it. How this is helpful is that you could possibly put this in a pipeline where the input of the second part of the input in the middle of the pipeline is of a multi-view diffusion, and now you can take this multi-view and create a 3D image or a 3D object, right? So you can input a 2D image and get 3D. Really cool. Lots of applications and fun stuff there, right? How this works is, firstly, you install the requirements. So it's just this file with a bunch of text. What the requirements is it just contains all the libraries you need to for a program to work, right? And it helps in reproducibility because anyone can take your requirements and they can just install all those and run your code, and it'll run hopefully the same, right? Then you import Torch, that's a library, that's just PyTorch. Then you import Diffusion pipeline, so that's a HuggingFace function, HuggingFace class, I believe. And what that does is it creates this pipeline for you. It's a lot of abstraction on top of a lot of low-level PyTorch code, which you don't need to worry about. This is just how it looks, the API. Then you take the pipeline you get from pre-trained. So what that means is you're taking a model that's already been already been trained, and you're just using it for inference. So inference is just taking a finished model and doing the actual function of it, right? Inferring what the output will be given an input. So it's already trained, you just give it input, it gives you output. Then you put the custom pipeline because this function doesn't know, so diffusion pipeline doesn't know what this model is, and therefore you're telling it explicitly that this is the custom pipeline. Then torch.dtype is just the type that you'll be inputting in there. So you'll just be inputting a float value, right? According to PyTorch. Then what this toCUDA does is it tells your computer, hey, don't use the CPU, use the GPU. Don't be crazy. A CPU is gonna take days or hours or something, whereas a GPU can hack away at it in no time. You do need a pretty decent GPU for this, so if you don't have a GPU, or if you don't have a strong one, you can feel free to use Google Colab or Kaggle Notebooks or whatever your preferred choice of web GPU provider is. Then you can import all this stuff. Basically what this does is it takes a URL, it gets it, and then you take the Python image library and you create an instance of a Python image using that data from the URL. And then what you do is, this is the actual important bit, you create the image grid. So it takes one image, so it would take this image, or it take whatever input image, and it would create a NumPy array. It would divide that by 255 to normalize it. Then it would put that into multi-diffusion pipeline. So this is the pipeline you defined up here. And the pipeline would do all the heavy lifting. So it would take the image, it would set all these parameters. So the only thing that you should be worried about is number of inference steps. So that's just how many times it does the diffusion process. So how many times it goes from noise to less noise. And the higher this number is, the more steps your diffusion model will do. And then you take these images and you just multiply them by 255 to get back the contrast and the vibrancy of the image, right? You're denormalizing it. Don't know if that's the official term, but I'm gonna go with it. You get the width and height of the image, right? So that's just to create the grid. So then in the grid, you get 2 times the width, 2 times the height. So now you're creating a twice as tall and wide blank image in which you just paste all your images. And then you return that grid of 4 images, right? So 0, 1, 2, 3, 4. Then what you do is you import Gradio and you create a Gradio interface. What this interface takes is a function. So the function we defined up here, as I said, it's the most important bit. It like puts everything together. Then you have the input, which is an image, and then you have your output, which is also an image. So you just put image in both of those, and then you can just launch your Gradio interface and it will look something like this. And that's pretty much it. If you enjoyed this tutorial, be sure to leave a like. If there's something I could improve, please leave a comment about it. With that said, have a great rest of your day. Bye-bye.